Bismillahirrahmanirrahim. As discussed earlier, there are many diode models are available in literature to simulate the electrical behavior of diode. In previous unit, we discussed ideal diode model, which is very good for rough approximation and has some very serious limitation. In this unit, we will discuss piecewise linear diode model, which is simplified representation of real diode behavior and as well as right from the ideal diode behavior. In this figure, solid black line is shown as a piecewise linear diode model, which is a simplified allow for the analysis of circuit and relatively more realistic than ideal diode. It approximates the diode characteristic using the linear segment, making it particularly useful in circuit design and analysis where high precision is not very critical. In forward bias condition of the diode, approximately as a linear resistor because voltage current relation is a straight line. So we we consider as a linear resistor with a fixed voltage drop. The voltage drop typically for standard silicon has a forward bias drop of approximately zero point 0.7 while germanium diode has zero point 0.3. The diode can be modeled as a RF in series with some power supply, some voltage, forward voltage drop. We will see in the next slide. When voltage is applied across a diode which is greater than VD, diode forward voltage, then diode forward bias current, which is equal to the V minus VD divided by RF, where V is the applied voltage, VD is the diode forward voltage, and RF is forward resistance of diode. In the reverse bias condition, the diode is treated as an ideal current model. In other words, there is no difference between ideal diode model and piecewise linear model in reverse bias region. So there is no current in reverse bias region by the piecewise linear diode model because it is open circuit. And now we discuss about the equivalent circuit model for piecewise linear diode model, which is consist of forward bias voltage source in series with a resistor to represent the diode behavior in forward bias region, alongside an open circuit for the reverse bias scenario. Specifically, this model incorporates a fixed voltage drop, typically zero point 0.7 volt for silicon diode as a voltage source denoted as a VD, which account for the threshold voltage necessary for the conduction. In series with this voltage source, a forward resistant RF models the diode dynamic resistance during conduction. In the reverse bias condition, the diode is represented as an open circuit, indicating that no current flows until breakdown occurs. This simplified equivalent circuit for piecewise linear models allow for straightforward analysis of circuit involving diode, facilitating some calculation for current and voltage in various applications without going to detail into complex nonlinear equation. Piecewise linear model has many applications in circuit analysis, just as for circuit for rectifiers, circuit for amplifiers, and clipping and clamping circuit, where precision is not the primarily concern. Piecewise linear diode model is also excellent work for simulation because it provides a quick way to simulate diode behavior in application, like clipping and clamping circuit. It provides some converging constant for very complex situation, complex model for diode. It has advantage like simplicity and ease of use, but other side, it has some limitation. One of the most important limitation is accuracy, lack of accuracy. The model does not accurately represent the exponential current voltage relation of real diode, especially at lower current or lower voltage near the threshold. Another important limitation of piecewise linear diode model is lack of temperature because it does not account for change in the diode behavior due to the temperature variation. And third one limitation is that piecewise linear diode model does not discuss about the breakdown voltage, which is very real behavior of many real diodes.